All right, so we are going to be talking about the lab that we did in class now. And so this lab is to take the gdelt data that we worked with on the very first during our very first Athena lab and convert that and optimize it basically. And so what I'm going to start by doing is copying this URL and going back to that same gdelt GitHub that we used last time. So this is the gdelt GitHub that we used when we were doing the Athena lab. We're going to use this again, and what we're going to do is we're going to take that data. So we remember that when we did queries, it took about 180 gigs of data searching to run a query. So it's not super efficient, right? That's just under $1 per query at that scale. So what we're going to do is we're going to take the data, we're going to use EMR to convert it to Parquet, which is the optimized format we talked about, and then we can use Athena, and it'll be much faster and it'll be much more efficient. So with this open, with the gdelt GitHub open, I'm going to flip back to the AWS console, so aws.amazon.com. I'm going to sign into the console, and we're going to use EMR. So I'm going to log in. And once we're in here, if you haven't used EMR before, you'll have to scroll down here to EMR, click on it. Now I am going to use it in North Virginia right here. Now if you get some kind of error, you may get one of two errors. If you get one that says, hey, that capacity couldn't be allocated, go ahead and switch to Ohio. Ohio's a fine choice. Or if you get another one that says, hey, your account has to be verified, wait up to 2 hours, there's nothing I can do about that. Basically, you just have to wait. So for starters, I'm going to go ahead and create a cluster right there. The blue button, your create cluster button may be in the middle if you've never created a cluster. You can call it whatever you want. I'm going to call it gdelt OU. I'm going to uncheck this logging. So this logging basically takes all the logs about what your server is doing, like what the jobs are, how the jobs are going, how things are running, and it saves it out to S3. I don't care about those, so I don't need those logs. You can see here there are a bunch of different versions of EMR, right? These are older releases of EMR. I'm going to leave it on the newest, even though, as we found in class, it'll give us a couple of errors. The errors do not stop the lab from working. You can also see here, I can select Core Hadoop, which comes with Hadoop 2.85, Ganglia, which we haven't talked about, Hive, which we've talked about, Hue, which we'll use, and then some other stuff. I could select different types like Presto, I could select Spark or HBase, and these just come with different pieces of software, as you can see here in the description. Next, you can see here I can pick an instance type. So M3 extra large just has, I think, 8 CPUs and 16 gigs of RAM. I can do a 2XL, which is twice as big. The 3 is a generation, so M3 is the 3rd generation, M4 is the 4th generation. I'm going to leave it as an M3XL, but I'm going to go ahead and bump this up to 8 workers. You can leave it at 3, you can bump it up to 8. All it does is, if you do 8, your job will finish faster, but it'll cost more money. So if you do 3 workers right here, if you do 3 instances, or sorry, that's 1 master and 2 workers, your job will, you'll pay about $1 an hour, and your job will take about an hour and 30 minutes or so. If you do 6, it'll be a little bit more than twice as fast, and you'll pay about $2 an hour. So that's kind of the trade-off, right? So if you have more workers, you'll pay more. So I'll probably be paying about $2 or $3 for this for 8 instances. But my job will take less than an hour, and I am interested in that right now. I'm not going to change any of this other stuff. I'm going to create my cluster. And so what we can see here is you'll go and it's provisioning my master, it's provisioning my core, which are my workers, and it'll take me just a couple of minutes to provision these. And so what's important to note here is my cluster is starting. If you get an error, you want to keep checking to make sure that your cluster is either terminated or if it starts, you want to go ahead and use it. So the thing to keep in mind about a cluster once I've started it, once I've told it to provision, is I will pay for this cluster until I turn it off. And so everybody in class remembers, I said this several times, is once I start a cluster, I need to remember to terminate it. And so if you get an error, you would want to make sure that the cluster terminated itself without assuming that, right? And so do not forget to terminate your cluster. You will continue to pay $1 an hour if you left 3, or $2 or $3 an hour if you did this size, until you terminate it. And so hopefully you would get the alert email, right, telling you, hey, your cluster is, you exceeded $25 or whatever, but you would definitely spend more than you intended. So terminate your cluster. And I'll show you that here in the lab. But basically, here you can see this cluster terminated. This one terminated with errors. So I tried to spin it up in West, and they didn't give me the resources, so it terminated, right? This one is starting. If it says anything other than terminated, you're paying for it. To terminate a cluster, you check it and you click this terminate button, right? So whenever we're done with this lab, whenever we're done with the cluster, that's what we're going to do. We're going to check the cluster's name right here, and we're going to terminate it. And then it will say terminated, right? And so keep in mind, whatever happens, whenever you're done, you want to make sure all of your clusters say terminated when you're done. And you do that just by checking it and clicking this terminate button, right? So that's probably the most important thing. It'll take a couple of minutes here to provision this worker and the core. So I'm going to go ahead and flip back to the gdelt GitHub. And so here we are. We see the exact same information that we had previously. I'm going to click here into the Parquet and the conversion. And so what I have here are 3 queries. I have one that creates a table that points to basically an empty bucket, right? And so this right here is the same bucket that we created in the Athena lab. And so I created one, I think, that's called Bruffett OU bucket. I'll actually go and check that by opening a new tab at aws.amazon.com and signing into the console and going to S3. So here's S3. And you can see I have a couple of buckets, and one of them is Bruffett OU bucket right there, Bruffett OU bucket. And so whatever bucket you made in that very first lab, that's the bucket that you're going to want to use. So I'm going to use Bruffett OU bucket. So what this very first query does is it creates an external table, which is what we did in Athena. Basically, it creates a table that points to files in S3. One column is the global event ID, so on and so forth, all the way down here. So these are all the exact same columns we used the very first time. But critically, it's stored as Parquet. It's stored in your S3 bucket. And then here I'm also setting the compression to snappy. And so when I make this bucket, when I make this table in Elastic MapReduce, it's going to be empty. And then I'm going to create another table, and this table points to that data in Google's bucket, right? So this is the same table creation query that we made in Athena, and you can see here it's all the same columns, right? And it's called gdelt.events, and it's tab delimited, right? It's got these same options that we ran last week, and it's located in the gdelt open data event. So this is Google's bucket, and so this table has data in it. It's not compressed data. This has no data in it, and it will be compressed. And then this query will copy data from, it'll select all the data out of gdelt.events, which is this uncompressed table that we made together, right? And it will copy all of that data into events Parquet, right? Which is empty, but compressed. And so EMR will take all that data, it'll read it all, and it will put it all in our AWS bucket, and it will compress it for us. And then we'll be able to query it with Athena and save ourselves some money, right? And so you can see here, my master node is bootstrapping. That means that I've gotten an instance. So provisioning means Amazon is going out, it's looking for a compute instance for me. And then bootstrapping means, hey, I've got your instance, I found it, and I'm installing software on it, right? I'm getting it ready for you to use. And so you can see it almost always starts the master sooner than the workers, and that's just because there's some specific configuration it does on the master to get it ready first. And so you can see I'm bootstrapping on the master, and it should be ready for me here pretty soon. And then usually the workers or the core nodes come online pretty quick after that, but we'll see. And so this process of getting machines, depending on the time of day, depending on how busy the AWS region is, could take anywhere from probably, what have we been waiting, 5 to 6 minutes now. It could take up to 15 minutes. And if at some point you say, hey, this is taking too long to start, I can't keep waiting, obviously you could come back here to clusters and terminate it. And you would still incur some charges, but it'd be pretty nominal, right? It'd be for however long you'd been waiting. You'd pay for about 5 minutes of the machine time if that's what you'd gotten. So it wouldn't be a big deal. So yeah, you could, but I would definitely try to allocate an hour or a little more to at least be able to monitor this this lab and terminate it when you need to. And so it's still bootstrapping here. So what I'm going to do while I wait, there is one piece of configuration that we need to do, which is, you can see here it says connections enable web connection. I need to do a piece of configuration to allow my computer to access my Hadoop cluster. And so by default, Amazon locks down all of the network connections to my cluster. Basically, they don't want people going in and using or hacking into the cluster I've created. And they do that by saying, hey, no computers can talk in to these machines, right? They secure it so that outside computers cannot talk to the cluster I've created. But what I want to do is I want to allow my computer, right? I want my machine, my computer, to be able to talk in and connect to the cluster I've created. Specifically, I want to connect to this master machine here because that's the one that I'll write my job on, right? I've got to connect to the cluster to create those tables and tell it to copy the data, right? So I've got to connect to the master machine. I do that by clicking this security groups for master right here. You see how there's a link, SG whatever. I'm going to click that link and it's going to open a new tab. And in this new tab, I can configure the networking rules for my Hadoop cluster that's in Amazon. And so you can see here I have one group. This is a network security group, and for mass slave for the workers, and I have one for master, right? So I'm going to click this name for master, and you can see here I have a description for that security group, and I have inbound. So these are the rules for what computers can talk in to my master node. And you probably don't have quite as many rules as this. I've created quite a few over time. Outbound basically means what can my machines talk out to. So what I want to do is create an inbound rule. I want to set a rule so that my computer that I'm working on can talk in, can open in and connect to the master node of my Hadoop cluster. So I'm going to click this inbound and I'm going to click edit. And I'm going to scroll all the way to the bottom and add rule. And this rule basically says all traffic, so I want to be able to make any connection I want from my computer to the master node. So all traffic, and this is what computer can talk in. So my IP, my computer's address, can send any traffic I want to the master node. And I'm going to save that, and it's going to close, and then I'm done. I'm done with this tab, so I'm going to go ahead and close that. Go back to my machine. I can see my cluster's running, which means my master has started, my workers have started, and now you can see since I made that rule change, I have these connections. So I can click Hue, Ganglia Resource Manager. I'm going to go ahead and click Hue, and it will open another new window. And here I get the Hue web browser or the Hue web interface that we've talked about. So I can create any username and password I want, right? The very first time you log into your cluster, you can create any username and password you want. So I'm just going to create it as rough3497. I'll go ahead and use Safari's password because honestly I will never need to log into this again, because when we're done I'm going to delete it. I'm going to go ahead and create an account and it will log me in. Once in Hue, it will give me the tour, which I don't really care about, so I'm going to close this. I don't care about the tour. And this is the error that I was talking about. Yeah, I've gotten this error several times before. We do not need to worry about it. I'm going to close it. So the very first thing I'm going to do, now I have a query editor, a lot like the query editor that we got with Athena, right? So the first thing I'm going to do is create database gdelt. And I'm going to run it with this little arrow command right over here to the left, execute. And it's going to go, it's going to give me this stupid error again, and it doesn't really matter, because you see here my query is running, and then I get a success down here. There you go, green check mark, my query succeeded. Good deal. I'm going to flip back to my gdelt GitHub and copy this query. I'm going to remove this create database and paste my query, and I have to modify this to point to my bucket. So in S3 I said my bucket was called Bruffett OU bucket, so I'll flip back, OU bucket, there we go. So other than that, I can leave this query as it is right here, and I'll run it. And again, I'll probably get that error up here, maybe not, but I don't have to worry about it. As long as I get a green check mark down here after it finishes, I'm all good to go. So I'm going to go ahead and go over here and copy this second query. I'm going to run that. So basically I've created the empty table, I've created the table with data in it. There we go, green check mark, good deal, seems to have worked. And now I'm going to copy the final query that copies from the table with data in it to the table that has no data in it. I can ignore this error. And paste that, and run it. You can see I got a green check mark. There we go. So what this is going to do, so you really don't have to worry about, you shouldn't get an error over here. If I look at databases and I refresh it, we shouldn't be getting these errors, but there's just a problem with this version of EMR and something with the Metastore. It really doesn't keep the lab from working, and it's just some issue that Amazon has with it right now. We can see the gdelt database appeared, but it won't show us any tables, even though we have error loading tables, and that's to do with this error we've been getting. So we don't have to worry about it. I'm sure it'll get resolved in some future release that we don't. But the lab works just fine. And so what we're doing here is I've created the database, created an empty table, created a source table, and now I have run my query. There we go, we see it, insert overwrite. And so what it's doing right now is it's taking this job, it's taking this large job, and it's breaking it down into tasks, and it's creating something in Yarn in my job manager, right? Here we go. So now it's taking it, it's executing on your Yarn cluster. That's what we've talked about, right? So it's Yarn is giving me resources, it's breaking the job down into tasks, and it's allocating the tasks across my EMR cluster. So we can see here it has broken it into 192 tasks, and now I'm allocating those tasks out, and so we can see now 10 of them have been allocated out. So if you see a larger or a smaller number, that's because your cluster is larger or smaller. So because my cluster has 7 workers, I'm going to get a pretty good number of tasks here going at the same time. If your cluster doesn't have as many workers, obviously you won't get as many. So you can see here I've got 26 now. And I think I'll get up to like 30. Yeah, there we go. I'm up to 30. And it's probably about as many as I'll get on this cluster, I think. And so now I can see here, if I click the jobs, I see here my job is running. It's at 0%. And what you'll find with these jobs is that it'll be at 0%, and then it'll probably jump up to like 5 or 10%, and it'll jump up to 16, 20%. And so if you refresh it right here, over time, and again, on this size of cluster, it'll probably take about an hour total, maybe a little less, maybe 40 or 50 minutes to complete. But eventually it'll say status succeeded, progress 100%, and my job will be green right here. It may go down to 0. Some folks saw that in class where it went up to like 70. Mine went to 70%, and then went to 0, and then after a few minutes it succeeded. As long as it's running, and as long as your query here, you see these tasks, and these tasks are running. Oh, there we go. I got up to 47. Never mind. It's a pretty big cluster. As long as these tasks are running right here, and you see these numbers changing, your job is continuing on, and it's working fine. And so I'll let this run for just just a minute or two, but in this video I'm not gonna wait for the whole thing because I've actually already done it. But at the end of the day, what you'll get is, if you go into your S3 bucket, what we did is we created 4 folders in class. We created countries, event codes, groups, and types. Just now we created a table in the events folder in S3. And here in events, once your job completes, you will see files. You'll actually see, in total you'll see 194, but 2 of these you can see is just a folder and a succeeded. And so basically you see 192 data files, which conveniently is equivalent to the number of tasks, right? So we create 1 file per task. And so once this completes, you'll get 192 files, and that's all of the data we need to create this table. So what I can do now, once your job completes in EMR, I can go into Athena, and if I create a new query, right, I can come in here to the gdelt. I can copy this query that created our Parquet table, right? I can copy this exact query, right? Create events Parquet. I can go in here to Athena and I can paste it, and I can make the same modification I did in EMR just now. I can go brafit OU bucket, right? I can run this query and it may fail for me, so there it goes. Yep, all right. And so what I did is now I have another table in here in Athena. I have the ones that we created in S3, right? I have the events table that references the Google data, right? This is the uncompressed Google data. But now I have the events Parquet, which is the data that I created with my EMR cluster that's compressed and optimized, right? And so the benefit of that, let's flip over here. The benefit of that, if I go back to gdelt and I go to gdelt, the home, and I go to queries, and these are the same queries that we ran in class in Athena, and I copy this very first Barack Obama query. And I paste it right here into Athena. Let's clear that out. All right, so this is going against the events table, the one that we used the very first night, the very first time. And so this query will take, I think it's about 20 seconds, and it'll come back with some results, and it'll scan about 180 gigabytes. And so that'll cost me just under $1 to run, basically, right? And so once this completes, I'll get my results up. So take it up, there it goes. So it took 22 seconds and it scanned 182 gigabytes, so it cost me about $1 to run. Now if I modify this, and instead of going against the events table, I go against that events Parquet table. This is the table that we just created, or if your job is still running, you're still creating this table, but mine is finished. If I run it against that, what we'll find is it takes dramatically less time. So in that case, it took just under 4 seconds, and it scanned 2.5 gigabytes. So this query literally cost me a couple of cents. I could run a whole lot of queries against a table at 3 gigabytes a pop before I got to the 5 terabytes that the 1 terabyte that charges me $5, right? And so what we did with EMR is we copied the uncompressed data to a compressed table, thereby optimizing it, right? And then we created a table in Athena on that data, right? So we took the data, we copied it, we compressed it, and now we're reading that data that we took and compressed ourselves, right? And we're saving ourselves a whole bunch of time and money in Athena. We could not do that in Athena because it does not support the insert statement, right? In this copy statement I have right here, oops, sorry, I changed it. In this copy statement I have right here in Parquet, I have this insert. This is not supported in Athena, right? So that is one of the limitations. I needed to use EMR to copy the data from one table to another to do that compression. But now that I've compressed it, I can reap the benefits here in Athena, and I can run all kinds of queries way faster and way cheaper. So now if I go back here to Q and I look at my job, I can refresh it and see, I should have made a little progress. Let's see. Let's go back to my query. So it looks like a couple tasks have finished. So 4 tasks have finished. That's what this 4 plus 50, so I'm 50 in. I've got 4 complete out of the 192. So I should start seeing my job update. I just need to be patient with the refreshes. Patience is not my virtue. But the bottom line is we'll start seeing some progress on here if you're running your own. And once this gets to 100, your data copy, your data conversion will be complete. And you'll be able to delete the data set. Or you'll be able to delete the cluster, sorry. Back to my query. There we go, we see 5, we see 7. Okay, so some of them are starting to complete. I'd like to see some moving my job though. There we go, 5% complete. All right, and so we'll see the job slowly continue to complete. And again, this will probably take a little bit longer, right? So after 8 minutes, we're 5%, which it'll get faster as it goes. But at the end of the day, watch your job. Once it gets to 100%, all of that data will be written out. You'll be able to access it in Athena. I'm not going to wait the whole time for it. But the deal is, once you see 100%, once you see that your job has succeeded, you can close Hue. And then the last step that is very important that you do not forget, very important. I'm going to go back here to EMR. Before I'm finished, I'm going to take this cluster, I'm going to check it, and I'm going to terminate it. So it's very important that whenever you're done with your lab, for whatever reason, right, your job succeeded, you got an error, you weren't able to connect to EMR for some reason, for whatever reason, whenever you said, hey, I don't have any more time to do this, I have to stop, right, I'm finished, you have got to terminate your cluster. You will continue to pay for your cluster until you terminate it, even if you never logged into it, even if you're not doing anything with it. So before you finish, before you stop, you need to check this box and terminate your cluster. And so you can see mine says terminating, and so I'm done. I have no clusters that say waiting, that say starting, that say ready, nothing like that. Every one of my clusters says terminated, so I am done. And I am not paying Amazon for anything anymore, right? I'm not paying them. So it's essential that no matter what you do, if you have a problem, an error, an issue, and you're gonna stop working on it, you have got to terminate your cluster. You are not done until you terminate your cluster. I cannot stress that enough, because until you do, you will continue paying them $1 or $2 or $3 an hour until you terminate it. All right. If you have any questions, let me know.